Hello everyone, this is the first homework video for Im1 homework number 8. So we're going to get started with this homework number 18. There are 8 problems. The first question is asking, solve each equation, show your work. For number 5 to 8, show verification work. Okay, so for 1 to 4, you do not need to show verification, but for 5 to 8, you do. Alright, so first thing, we have absolute value of a variable a is equal to 6. That means, what could a be that would give absolute value of a to be 6? Well, since we know that if I have absolute value of 6 is also going to be 6, as well as absolute value of negative 6 is going to be 6. We have two options, two possibilities that a could be. A could be positive 6, which is here, and a could be negative 6. What about number 2? N over 7 is equal to 2. Okay, so again, since we have the absolute value sign isolated on one side of the equal sign and just a number on the other side, we need to consider what's inside the absolute value symbol could be positive or negative. So I am going to break this up into two different branches and say that n over 7 could be positive 2 and n over 7 could be negative 2. Okay, so there are two different possibilities. So now notice that when we consider the two different possibilities, the absolute value symbol disappears. So when we consider two different equations, then the absolute value disappears because we have basically applied it. Okay, now we don't want n divided by 7, we want just n. So how can we get rid of this 7? 7 is being divided from n, so how can I undo divide by 7? We multiply both sides by 7. And that would give us, that would cancel out to be my giant 1, and that leaves us with n is equal to 12. And the other side, again, I multiply this side, both sides by 7, and that leaves us with n is equal to negative 2 times 7 is negative 14. Okay, mistake, it should be n is equal to 14 to begin with. Okay, so now I have two different possibilities, that n could be positive 14 or n could be negative 14. Well, as the first question, the a could be positive 6 or negative 6. Alright, what about number 3? Again, we have just the absolute value symbol. It doesn't matter what's inside, okay? As long as you just have the absolute value symbol, you can break this into two different possibilities. So 4r could be equal to third positive version of 36, or 4r could be negative version. Okay, so because even if what was inside was positive or negative, it's still going to give positive as your final answer. Then from here, I divide both sides by 4 because 4 is multiplying to r. So that leaves me with 36 divided by 4 is 9. Positive divided by positive is positive. What about this side? We divide both sides by 4 again. That becomes my giant 1 and disappears, and you're left with r is equal to 36 divided by 4 is 9. Negative divided by positive is negative. So you have two options. R could be 9 or R could be negative 9. Oops. I'm sorry, you can't see it. Alright, so that's my one. Alright, then what about P? 4 absolute value P is equal to 12. Okay, what do we have here? We have absolute value of P here, but we have some number outside. That means, remember, we want to isolate just the absolute value symbol. It doesn't matter what's inside, but outside we need to take care of it first. So we need to get rid of this 4 first before we deal with the absolute value. So how do I get rid of this 4? 4 is multiplying to absolute value. So there's an invisible multiplication there. So that means we're going to divide both sides by 4. when I do that, that becomes my giant 1. And I still have P with the absolute value is equal to 12 divided by 4 is 3. Notice that the absolute value symbol is still there because we have not taken care of it yet. Okay, but now we can split this equation into two different versions. That P, what's inside, could be positive 3, or P could be what's inside, the P could be negative 3. So we have two different versions. Let's keep going. Now 5 to 8, we do need to verify. Okay, so here, now again, we want to isolate the absolute value symbol first. Okay, so we just want this sign is equal to. That means we need to get rid of this plus 10. How do I get rid of this plus 10? What is opposite of plus adding 10? That's going to be subtracting 10 from both sides. That becomes my 0, and you're left with absolute value of n is equal to 11 minus 10 is just 1. Okay, now that I have just the absolute value symbol with things inside is equal to 1, I can split this into two different versions, and n could be equal to positive 1 or n could be equal to negative 1. Alright, and that's it. Those are my solutions. But now I need to go through the verification process. So I need to verify. Verify means find your solution and substitute it into the original equation. So instead of 1, whenever I see from the original equation is absolute value of n plus 10 is equal to 11. So I am going to break that up into two different branches. And, alright, I'm going to first consider n is equal to 1. So whenever I see a n, I'm going to replace it with 1. Oops, is equal to 11. So we're asking ourselves, is this true? When I substitute that in, if it is a solution, if I did not make any silly mistakes, then it should come out as true. Well, now that I know, since I just have an absolute value of a number, I can take absolute value of 1. What is absolute value of 1? That's just plain 1. Notice that the absolute value symbol is now gone because we've applied the absolute value of 1. And plus 10 is equal to, well, we still don't know because we have not simplified the left-hand side. 1 plus 10 is equal to 11, and the right-hand side is equal to 11. So that is true. So I know that n is equal to 1 is a solution. What about n is equal to negative 1? So again, I am going to substitute it into the original equation. Plus 10, is that equal to 11? That's the question mark. Well, absolute value of negative 1 is also 1. And notice that the absolute value symbol is now gone. Plus 10. Is that equal to 11? 1 plus 10 is equal to 11. And that is same as 11 on the other side. So it checks out. So I have verified that both n is equal to 1 and n is equal to negative 1 are correct solutions. Let's go on to number 6. Okay. Now that I have on the number 6, I just have absolute value of something is equal to 22. I just have absolute value symbol on the left hand side. It does not matter what's inside. Okay. So I just have isolated absolute value symbol. That means I am ready to break it into two different branches. I consider what's inside the absolute value, which is 10 plus 4k, could be the positive version of 22. The other possibilities is what's inside, that's 10 plus 4k, could be negative version, which is negative 22. Alright, so then from here, what do? When you have two-step equation, 4 is being multiplied to k, and then we are adding 10 to it. So the last thing that was done to this equation was adding 10. So that means we need to subtract 10 from both sides first. to get rid of this. Okay, so that leaves me with 4k is equal to 22 minus 10 is 12. Then from here, I divide both sides by 4. And I am left with k is equal to 3. What about the other side? I need to subtract 10 from both sides again as well. And that leaves me with 4k is equal to negative 22 minus 10. It's not negative 12. It is, you're becoming more negative. That's negative 32. So then from here, I divide both sides by 4. And that leaves me with k is equal to 32 divided by 4 is 8. Negative divided by positive is negative. Okay, so I have two solutions. K is equal to 3 or k is equal to negative 8. Okay, now common mistake is that when students find the first solution, they just immediately think the other solution is the positive version of 3 or negative version of 3. Notice that k is not negative 3. K is a different number. K is negative 8. So you do need to consider the two equations separately. Okay, so make sure you do that. I still need to go through the verification. And the original equation was 10 plus 4k, absolute value is equal to 22. So I'm going to consider k is equal to 3 here. So that means 10 plus 4 times 3, absolute value of that, is that equal to 22? And the other version with k is equal to negative 8 is absolute value of 10 plus 4 times negative 8, close absolute value, is that equal to 22? So let's verify each of the branches separately. Okay, so now let's simplify what's inside, because absolute value is a grouping symbol. That means you need to evaluate what's inside first. We need to multiply 4 times 3 first. 4 times 3 is what? 4 times 3 is 12 plus 10. We still have not applied the absolute value symbol yet. We're asking, is this true? Well, 10 plus 12 is 22. We still haven't applied the absolute value symbol yet. But now that we just have a number inside the absolute value, we can apply that. What is absolute value of 22? That is just plain 22, and that is equal to 22 from the other side. So we have just verified it. What about the other side? Again, we need to evaluate what's inside the absolute value first. That's 10 plus 4 times negative 8 is going to be negative 32. So it's 10 minus 32 is going to be negative 22. That 22 is from just the other side. And absolute value of negative 22 is 22. Okay, notice that at the end, I have 22 is equal to 22. So that checks out. I know that those are both valid solutions. Okay, so then let's keep going. Absolute value of negative 6 minus 3x is equal to 3. So what's inside could be positive 3 or negative 3. So 6 minus 3x could be positive 3, or 6 minus 3x could be negative 3. So I'm going to quickly subtract 6 from both sides. That leaves me with negative 3x is equal to 3 minus 6 is negative 3. Then from here, I am going to divide both sides by negative 3. And that leaves me with x is equal to negative 3 divided by negative 3 is just positive 1. The other side, I subtract 6 from both sides again. That goes away, and you're left with negative 3x is equal to negative 3x. 3 minus 6 is negative 9. Then divide both sides by negative 3. And I am left with x is equal to negative 9 divided by negative 3 is positive 3. And here's my verification. That's my original equation, and I'm substituting each of the solutions that I got separately and coming up with a true statement. Okay, I'm going to continue with number 8 in the next next homework video.